the body is at the state of rest, then force can change their state from rest to motion and vice versa. Or we can say force is pulling or pushing of a body. So today's topic is pseudo force. So before going to the actual definition of pseudo force, we have to know why we use this concept or why we need pseudo force. So here you can see force. The force acts on a body is directly proportional to rate of change of momentum of a body. This is the basic definition of force, or you can say Newton's second law of motion. That is, the force acts on a body is directly proportional to rate of change of momentum of a body. And in mathematics or mathematically, you can say momentum is equals to mass multiplied by velocity. And the symbol of mass is m, and the symbol of velocity is v. And you can say SI unit of momentum is kg meter per second. Okay, so from first you can say F is directly proportional to dm by dt, and after replacing the sign of proportionality, you can say F is equals to k multiplied by dm by dt. Suppose k is equals to 1 and applying derivative here, you can say d multiplied by mv by dt, which is derivative of momentum with respect to time. That is rate of change of momentum is equals to force. Now applying quiescent rule of derivative, we obtained F is equals to m multiplied by dv by dt plus v multiplied by dm by dt. Now case first, when dm by dt is equals to 0. From this expression, we can see if dm by dt is equals to 0, then this term vanishes and only this term is remaining. So we can say F is equals to m multiplied by dv by dt. And you know A is equals to acceleration, which is equals to rate of change of velocity. That means A barabar dv by dt. So we can say F is equals to ma. Now case second, when dv by dt is equals to 0. When dv by dt is equals to 0, then this term vanishes and only this term is remaining. That means v multiplied by dm by dt. Okay. Now here a question is given. In this question, is the given block move in forward direction? If yes, find its acceleration, and mass of the block is given, which is equals to 10 kg. So this is our question. Now you can see here, this is our surface on which the block is placed. Now a force F is equals to 20 root 2 Newton is act on this block by making an angle of theta, which is equals to 45 degree. Now another force is also applied in this direction. Now here given inclined force. So first we have to resolve this into two horizontal component. As you all are familiar with basic angle, which is alternating angle, you can see from figure, if this theta is equals to 45 degree, then this is also theta, which is alternating angle, and theta is equals to 45 degree. Now This is theta, and this is our horizontal component. Also, a vertical component is arises here due to this inclined force. Now, here horizontal component is equals to F cos theta by resolving this force, and vertical component, this vertical component is equals to F sin theta. Since here we placed a rigid surface, that means there is no vertical motion. Now let's check F cos theta is greater than this 10 Newton or less than 10 Newton. If F cos theta is greater than 10 Newton, then this block moves in forward direction. Otherwise, in backward direction. Okay, so F cos theta, this F cos theta is equals to F, F is 20 root 2. So here you can see 20 root 2, 20 root 2 multiplied by cos theta, and this theta is 45 degree, so we can say cos 45 degree, which is equals to 1 by root 2. Now this root 2 and this root 2 vanishes, only 20 remaining, so F cos theta is equals to 20. That means in this direction applied force is 20 Newton, and here in opposite direction we can see 10 Newton force only applied. So we can say the block is moving in forward direction. Now if the block is moving in forward direction, then what will be the acceleration of this block? What is the value of A? So let's calculate this. Now here acceleration A is equals to F net by mass. That means F net is equals to ma, here dm by dt. That means dm by dt is 0 given. There is no reduction of mass here, so this term vanishes. Second case is applied here. It is second or first, let's see. Here the first case is applied. So now F net is equals to 20 minus 10, because see here, if we apply here in this direction 20 Newton force, suppose I applied here 20 Newton force, and let's break this 20 Newton into 10 Newton and 10 Newton. 10 Newton force and 10 Newton force. The sum of 10 Newton and 10 Newton is equals to 20. So I break down this 20 Newton into 10 Newton and 10 Newton. So here we can say this 10 Newton force balances this 10 Newton force, and extra 10 Newton force is here available. So just we can say F net is equals to this 20 Newton minus 10 Newton by mass is also given, mass is 10 kg. Okay, so mass is 10 kg is given, that means A barabar 20 minus 10 by 10, which means A is equals to 10 by 10, that is acceleration A barabar 1 meter per second square. Okay, I hope this question is easy. Now what is pseudo force? Here first we see another name, that means What are the various names of pseudo force? After that, we will see what is pseudo force. So, pseudo force is also called fictitious force or D'Alembert force. This is another name of pseudo force, and it is an apparent force that acts on all masses whose motion is described using non-inertial frame of reference. Now, what is this non-inertial frame of reference? So this frame of reference is nothing, just frame of reference means anything, any reference surface from which we can calculate our coordinate. So let's see example of pseudo force. So a rotating reference frame, that is surface of Earth. Okay, so what is inertial frame of reference? You can see the reference frame which are at rest or moving with uniform motion. Uniform motion means their acceleration is zero. A is equals to zero. That means dv by dt is equals to zero. A बराबर zero. With respect to Earth is called inertial frame of reference. And if acceleration is equals to zero, if acceleration is equals to zero, we can say inertial frame of reference. Now see here, Newton's laws of motion are applicable in inertial frame of reference. Newton's laws of motion are only applicable in inertial frame of reference. We cannot apply inertial frame of reference in all cases. Okay, so concept of pseudo force is not required in this inertial frame of reference, and example of inertial frame of reference is a person sitting in a car moving with uniform motion in a straight line is inertial frame of reference. Okay, now what is non-inertial frame of reference? The reference frame which are moving with acceleration with respect to Earth are called non-inertial frame of reference. Non-inertial frame of reference means they are moving with some acceleration. They have some acceleration. That means velocity is not uniform. That is, dv by dt is not constant. Now, Newton's laws of motion are not applicable in non-inertial frame of reference. We cannot apply Newton's second law of motion in non-inertial frame of reference, so we need the concept of pseudo force. So to apply Newton's laws of motion in non-inertial frame of reference, we consider existence of imaginary force, which is called pseudo force.